Hey everyone, and welcome back to Shazmaths. In today's video, we're going to discuss a bit more detail about the concept of domain and range. We'll be discussing what our approach should be like whenever we are asked a question about the domain and range, and we also will be doing a few examples just so that we do have the understanding of the concept of domain and range. So let's get on to it straight away. So guys, there are two types of domains. The first one is known as the maximal or implied domain. Now in such questions, the examiner expects us to know the concept of maximal or implied domain, and he can ask us the domain and the range of the function in the same question. Whereas the second type is known as restricted domain. Most of the times in the case of restricted domain, the examiner will provide us the domain and he will ask us about the range of the function. Alright? So let's have a look at what exactly is a maximal or implied domain. So whenever the domain is not specified, the maximal domain, I'm just going to write it down as well. So whenever the domain is not specified, the maximal or implied domain is all the values of x for which the function is defined. Or the function results in some real value. Now these two words are very important. Defined and the function has some real value. Alright? So what is a maximal domain? All the set of values of x for which the function is defined or has some real value. Now in mathematics, there will be only two cases where the function will be undefined or the function will not have the real values. Alright, what are those two cases? Let's have a look. The first case would be whenever any number is divided by 0. Okay, in other words, whenever 0 is in the denominator of a fraction, that would always result in an undefined value. So the second case is whenever we have a negative sign inside the square root. For this type of scenario, there would always be complex roots. In other words, the roots will not be real. Okay? So the domain will be all the set of values of x that would not result in these two conditions. Okay? That means all the set of values of x for which the function should not have these two conditions. Alright? Those will be the domain. Let's have a look via an example so that we do have a better understanding of what exactly are we talking about. In this first example, it says the function f of x is defined by square root of x, and the examiner is asking us find the domain of f of x. Now we do know that in this scenario the examiner is expecting that we should have the concept of maximal or the implied domain, and what we have discussed above is that the domain will be all the set of values of x for which the function is defined. In other words, we should not be having a negative sign inside the square root. Now that means, just taking forward this concept, I'm just going to solve this. So that means the term inside the square root should be 0 or positive. It cannot be negative. So the domain would be x is greater than equal to 0. That's it. It's just As simple as that. In this second example, the question says f of x is equal to square root of x minus 7, and we have to find the domain of f of x. Again, we'll be taking forward the same concept, alright? So whenever you are handling or you're facing the questions of domain, I want you to think about these two concepts only. The first one is the domain is a set of values of x coordinates. In other words, it is the set of values of x. The second is, it is those set of values of x for which the function is defined. Okay, so I'm gonna always be using those two concepts to solve the questions of domain. Okay, let's apply that over here. So again, for this one, the term inside the square root, this one should never be negative. In other words, it can be 0 or greater than equal to 0. Alright, that means it can be 0 or positive. So the domain would be x minus 7 should be greater than equal to 0. And what would that be equivalent to? This would be equivalent to x is greater than equal to 7. So that is the domain. In this third example, the function f of x is equal to 1 over x minus 2, and we have to find the domain of f of x. Now, because we can observe that this function contains a denominator, right? And we have previously discussed that whenever a fraction is involved, the function will always be undefined whenever the denominator is equal to 0. Alright, so let's find out that for which values of x this function will be undefined. And we have already discussed that the function is undefined whenever the denominator is equal to 0. So I'm going to use the same condition, that is x minus 2, that was the denominator. So I have used that condition and I've put that equal to 0, and that would result in x equals to 2. That means for this value of x equals to 2, the function is undefined, right? And if you recall the definition of the maximal or implied domain, it was all those set of values of x for which the function is defined. In other words, the domain would be all the values except x equals to 2, because the function was undefined at x equals to 2. Alright, I'm going to write the same statement. So the domain is all real values except x equals to 2. Okay, now how would we represent this mathematically? We will say x is element of all real numbers except the value 2. So this is the answer to this question. So guys, after watching this video, I would expect that you would at least know that what needs to be done in order to find the domain of a function. The second type of domain that we have not discussed yet was the restricted domain, and that is mostly given or provided to us by the examiner in order to find the range of the function. We'll talk about it in the next video. Until then, I hope you guys like and share this video, and I'll see you guys in the next video.